Good morning, class. Allow me welcome you to this morning lesson. This is an A-level lesson, paper 1. The book is Backhouse 1, and the topic we are currently doing is trigonometry. We shall be work through a few more numbers from number 6. Then between 7 and 16 we shall choose a number. We shall do a part on 17 and do a part between 18 and 30. We shall do there another one part, and then we shall see whether we can make a small introduction on the T formula. That was supposed to be my intention, but I asked for whether you got challenges in 17C, and I want challenges there, then we can proceed if possible. But we should still be able to proceed. So enjoy the lesson. Today is I forget the date, but I think it should be the 19th if I am right. If it's not right, ignore it. And let us start by looking at number 6. Number 6 says that if t is tan 22 half, degrees, of course, they want us to use the formula for tan 2t, for tan 2t, for tan 2 theta, sorry, to show that that t squared plus 2t minus 1 is equal to 0, and hence deduce the value of the tan 22 half, and hence deduce the value of tan 22 half. So we start with this one. Recall is expected to be what we know. We already know for a fact, I am assuming, that from our double angle formula, which they have told us we should use, that the tan of 2 theta is equal to 2, the tan of theta out of 1 minus the tan squared of theta. We already know this. Now, if they are telling us that t is equal to tan 22 half degrees, this implies that if we look at 22 half, it is at this position. It means that t is actually equal to tan of theta, implying that theta is 22 half degrees. So if theta is 22 half degrees, this further implies that 2 theta is 45 degrees. It further implies that 2 theta is 45 degrees, which implies that the tan of 2 theta will be equal to the tan of 45 degrees. And even if you use the calculator, but if you remember from our triangles of common angles, the tan of 45 is 1. So from this expansion, which I'm now calling star, I will say that from star, tan of 45, after showing that theta is 22 and a half, will be tan of 2 times 22 and a half, which will give us 45 degrees, is going to be equal to 2, the tan of theta out of 1 minus tan squared theta. Now, since tan of 45 is 1, I will now substitute in and say it will be equal to 2 times t, because we are given that t is tan of 22.5, and 22.5 is theta. We already know this. So if we substitute for theta as over 1 minus t squared, and if we rearrange by cross multiplying, we will get our 2t being equal to 1 minus t squared. If we rearrange everything by taking it to the left hand side, we'll get t squared plus 2t minus 1 is equal to 0 as required by the examiner, as required. Basically, that is part of the solution. But they are asking us that now that we have shown this, we should be able to deduce the value of tan 22.5. Hence, deduce the value. Deduce the value of this. To find the value of tan 22.5 degrees. They want us to find the value of tan 22.5 degrees. Remember, we have from up there, I've told you that tan of 2 theta, which we know is given that theta is 45 degrees, the tan of 2 theta is 1. Not so? The tan of 2 theta is 1 in this case. So they are asking us to find the tan of theta. What is the tan of theta equal to? If the tan of 2 theta is 1, what is the tan of theta equal to? If the tan of 2 theta is 1, what is the tan of theta equal to? That's what they are asking us. And remember, they are telling us that this t we are having in the expression is 22.5. So what do we do to get the tan of 22.5? We look at the tan of 45. Now directly, that this is going to be equal to the tan of 22.5 over 1 minus tan squared of 22.5. When we do it this way, we know this is 1. So it means ideally it would come from here. But let me use this, that since this is 1, we are saying, actually, they are asking you to find the value of t here. If we solve this, we should be able to get t, and when we get t, we have got the value of this. So I can pick it from here and choose to solve for t. I solve that quadratic equation. This is the second alternative, but I can directly use the other one. Maybe you'll try to use this one. T squared plus 2t minus 1 should be able to give us the tan of 22.5 degrees, since t is equivalent to that. So we look for factors of 1. Two numbers we multiply to get, you notice that this may not be easily factorized. So we shall bulldoze it and say that t will be equal to the minus of 2 plus or minus the square root of b squared, which is 2 squared, minus 4 times a times c all over 2 times 1. If we proceed, we will get our negative 2 plus or minus. We shall get, this will be 4 plus 4 over 2. And if we proceed, we shall get minus 2 plus or minus the square root of 8 out of 2. But you are all my students, and I think all of you know that root 8 can be expressed as root 4 times 2, which is 2 root 2. So if I replace that as 2 root 2, the plus or minus is because the square root of a number is always a plus or minus. In other words, has two values. then we'll get our t is a minus 2 here. Our t will become 1 plus root 2 or negative 1 minus root 2. So it implies, therefore, that the tan of 22.5 degrees is actually equivalent to minus 1 plus root 2 or the other one. And if we compute this, ideally a minus 1 plus approximately 1.414 will give you around 0.414. And if you take on your calculator the tan of 22.5, it will be approximately that, to 3 decimal places. I'm not going to take it to another page, but it implies that we will take this and discard this one. So this will be discarded, and this will be the correct answer for the tan of 22.5 degrees. If you check in the book, it should be able to give you 0.14 or root 2 minus 1, which is the same as this. This can be written as root 2, then you take away 1. Note that the 1 is not under the root. The 1 is not under the root. If you did it this way, you would still get the same answer. I can verify that. If you chose to go back, this alternative, and use the tan of 45 is equal to 2 tan of 22.5 over 1 minus tan squared 22.5, definitely it will take you back to what we have been doing, but you will be having this instead of t. If you cross multiply, you will have 1 minus tan squared 22.5, because this is 1. If you multiply it by that, it says that will be equal to 2 tan squared, tan 22.5, sorry. So you'll have 2 tan 22.5, which is that one, plus tan squared 22.5 minus 1 becomes equal to 0. Now, if you let like it is, the tan 22.5 is t, you will get what we have just been solving. The t squared plus 2t minus 1 is equal to 0. And we are saying solving gives you t as root of 2 minus 1 or minus 1 minus root of 3. So we discard this one. We discard this one and consider this as the only correct solution. And therefore conclude and say that the tan of 22.5 degrees will actually be equal to root 2 minus 1 as required. Between 7 and 16, I am going to choose, last time I did one number to guide you, but I'm going to do another number there. And this time round, I don't know the number I did last time. But let me do number 13, which looks a little complicated. I hope it was not the one I did last time. I do not want to try out the one I did. Let me first confirm. Okay, so we can choose to work through number 13. Number 13, we are dealing with 17C and building capacity for you to be able to try out the other numbers. 13 is 2, the sine of theta, all into 5, the cos of 2 theta, plus 1, is equal to 3 the sine of 2 theta. And they are telling us to find values of theta in the range. The range is 0 to 360 degrees. This language, you all understand it better by now. I will say that to start with, we should be knowing at this stage that sine of 2 theta, which is a double angle, is 2 sine theta, cos theta. And then cos of 2 theta has 3 different expansions, which I will pull out all. You don't know which one will be suitable. We have that one. We also have this one. We also have this one. You should be knowing all of them. And we can also pull out that we know that the sum of the sine squared and the cos squared is also equal to 1. This is alone, this is alone, and this is alone. We may need either of those. So I'll begin by substituting in for sine 2 theta and later for that one. So it means I will have 2, the sine of theta, into 5. The cos of 2 theta, we can first leave this, plus 1, should be equal to 3 times 2, the sine of theta, cos of theta. At that stage, we can choose. Usually here we don't encourage crossing. We notice this is 6, and this is sine of theta. So we can say we will have 2, the sine of theta, into 5, the cos of 2 theta plus 1. We can bring this side. Minus 6, the sine of theta, will be equal to 0. Now, if we blow this out, we notice that the 2 sine of theta will be common. 2 sine theta is now common to all these. So I can first keep this angle there. And now if I have pulled 2 sine theta here, I have minus 3 cos of theta is equal to 0. I hope we are together. I want to repeat by saying this 2 sine theta is common here, but this is the same as this. It came from here. So I pulled out these 2 sine theta that I'm circling with a pen because it is common. So I'll stay with 3 cos theta as you see it here. Now, inside the brackets, I am now going to open this. But because I have a cos, I'm going to open it with a cos expansion. So I will use this expansion here. This one for the double angle. And I will have my 2 sine of theta into 5 into 2 cos squared theta minus 1 plus 1, this one is that one, minus 3, the cos of theta is equal to 0. I'll open the interior bracket and I'll make the correction of any like terms in the next stage. So when I open the interior bracket, I'll get 10 cos squared theta minus 5 plus 1 minus 3 cos of theta is equal to 0. This will give me 2 sine of theta into the 10 will stay, cos squared theta. I will bring the 3 closer, cos theta, and I will take away the remaining 4 and equate this to 0. Now I have, at this stage, I have 2 expressions. I'm going to first work on the interior. The interior is a quadratic equation in itself. That means that I have, if I use the AB condition is equal to 0, In the two numbers you multiply, you get 0. I will automatically get that 2 sine theta is equal to 0. And meanwhile, I already have angles here that I can get for theta as 0. So the values of theta that give us 0 will be, using your calculator, you can look for the angles that give you 0. One of them will be 0. I think the other one will be 180. Sine of 180 is 0. And the other one will be 360. So we already have these as the answers standing in waiting. They all fit within the range. Now, if we consider the other part, which should give us other angles. 10 cos squared theta minus 3 cos theta minus 4 is equal to 0. This is the other part. We look for two numbers, we multiply to get 40 and add to get 3. And these must be factors of 40. And quickly you will notice that 5 and 8 will qualify. 8 being negative. If we fit them in here, we shall have 10 cos squared theta, the 5 is positive, so plus 5, the cos of theta, minus 8, the cos of theta, minus 4 will be equal to 0. We factorize this. I'll turn it over and repeat it for purposes of consistency before I proceed. This is what we've got. And we are going to factorize this. You notice that 5 cos theta is common. We pull it out. And 10 divided by 5 is 2 cos theta because it was squared. And this will be 1. When you do the first bracket very well, I always tell you that the second bracket will have an interior that is similar to the first one. And our task is to look for what should be here. And this will be 4. And because of the negatives up here, negative. So we merge this, and then we take one of those twins. I call them twins. So 5 cos theta minus 4. Sorry, it's a minus. Sorry for that untidy work. Into 2 cos theta plus 1 is 0. So again, the AB condition will work, and this will give us 5 cos theta being equal to 4, and cos theta is 4 out of 5. So we will get the values of theta here as the values whose cos inverse is 4 over 5. We are going to get that. Then also, from the second one, 2 cos of theta plus 1 equal to 0 will give us cos of theta as negative a half. And we are going to get the values of theta also that give us negative a half. Now to get the values of theta, you are aware, get your calculators and we move. Remember, our all students taking coffee, chemistry. This is a course, we start with this. It is positive as you see it. That means it must have an angle here and an angle here. That means all these angles are in the anti-clockwise direction because they are positive. With my calculator, I get the second inverse or second function of the cos of ideally it should be 0.8 if you can tell straight away. In the first value here will be 36.87 degrees. Now if that is the first value, it is in here, or it is like this, it is this angle. So this other balance from 360 is also correct. When you take it away from 360, it gives you an angle that will now be in this quadrant. In other words, when you come to 360, you take off this 36.30, it gives you an angle which will be 323.13 degrees, which will also be correct. If you go another step, you will be going outside the range because you'll get 360 and again add on the first angle, which will give you around 396.87. So since that will be outside the range, we leave those two angles for that and we move to this. Since this is a negative, it implies that it is not here and it is not here. It is in these two quadrants. So we look for these two angles in those two quadrants by getting second function cos inverse. Second function cos, you press the shift button, you press the cos button, you get the cos arctan of arc cos, and you put in your negative 0.5. It will give us 120 degrees. The first value here is 120 degrees, and this is a positive angle here that you measure like this. It's a positive angle from 0 to there is 120. The next angle is in this quadrant, and that means to be 360 minus 120. You come up here and you take off that 120, so it gives you that positive remaining angle here of course 240 degrees. If we attempt to move to another angle, we shall definitely get an angle outside the range, and therefore I can now conclude and set all the values of theta within the range, starting with the very first ones we got. The first one was 0. The next one is going to be 36.87. The next one, we are writing them in ascending order, is 120 degrees. The next one is 180. Remember, we had 0, 180, and 360. The next one here will be 240. The next one here will be 322.23, 323.13, and lastly we shall have 360 degrees. These, I expect that they are the correct angles required for our number. It is number 13. It is number 13, and I will shortly be focusing you on the answers. You see them and you notice. If you do a good job, you will always get the correct answers. I want you to see these answers. Look at number 13. I'm going to touch. I'm now in the index of the book, and I'm going to touch there with a pen. If you see the line where my pen is, we have 0, we have 180, we have 360, we have 120, we have 240, we have 36.9. They have rounded it off to 1 decimal place. We had 36.87. They have 323.1 degrees. So you actually should be able to identify all the angles if you are consistent. If we had crossed out the other sign at the start, we would miss out some angles. Now, that number 13 that we have gone through should enable you to be able to try out all the other numbers from 7 to 16. Of course, the one we have done, you don't need to repeat. Number 17, I still remember doing a number there, but no problem. We can look at one more number there. I will do part C. Part C of 17 is they want us to eliminate theta. They are saying x is tan of theta, and then y is tan of 2 theta. Eliminate theta. To eliminate theta, I'll take y and say that since we have even just from the number 6 we started with, we know that tan theta is 2 tan of theta over 1 minus tan squared theta. We start from here. So tan of theta is y. Now I can substitute in. This is from y. I can substitute in here and say y will be equal to 2 times x. I think you agree with me that tan theta is x over 1 minus x squared. Usually for consistency and good arrangement, we don't leave the answer here, but ideally, if you left it there, you have already eliminated theta. We can take it an extra mile and say that our y minus yx squared will be equal to 2x. And since our interest is to eliminate theta, and we are looking at part C, as I said, we can neither leave it here or here. The book leaves it here. Ideally, you will have eliminated theta as they want. So for numbers where they say eliminate theta, you should take note that at some stage you may be required to pick any of the identities. You may be required to pick any of the identities that we have been proving over time. For numbers 18 to 30, this time around, let us look at number, I don't know which number I did last time. I think I did the number 29. Now we can do number 19. Number 19, this is saying proof. Proof. 19 says there's the sine of A over the sine of B plus the cos of A over the cos of B is equal to the sine into A plus B over the sine of 2B. I will prove the left-hand side. I'll prove the left-hand side. But even if I wanted, I could prove the right-hand side. Now, left-hand side, if I start away, I'll take the LCM, which will give me sine B